Okay, let's look at algebra of functions. We are very quickly going to go through this. This gives you two functions and tells you to do certain operations on those functions. Operations means like add, subtract, multiply, and divide. And so you have a little bit of kind of a key here to show you how to separate this out. If you have f plus g of x, you're writing f of x plus g of x. If you have f minus g of x, you're writing f of x minus g of x, and so forth. F times g of x, f divided by g of x. The biggest thing I want you to remember here is that this notation does not mean multiply by x. It is saying you've got two functions that you're adding together and the variable in those functions are x, okay? So do not multiply by x here. All right, let's look at this first example here. Given f of x equals 3x squared plus 2 and g of x equals 5x squared plus 7x minus 1, find f plus g of x. So essentially this is f of x plus g of x. So you're really just adding these together. F of x is 3x squared plus 2 and g of x is 5x squared plus 7x minus 1. Now, we have done a lot of solving in the past. This is not solving. This is simply putting these things together using the operation they're giving us, which is positive, and then adding like terms. So let's add our like terms here. 3x squared and 5x squared is 8x squared. And then we have 7x. And then 2 minus 1 is 1. And that's it for that one. Okay, let's look at the next one. It says using the above functions, find f plus g of negative 1. So we have already found f plus g of x. This is basically saying x is now negative 1, and we want to plug that into f plus g of x. So we have f plus g of x here. We're just going to take negative 1 and plug it in. So this would be 8 times negative 1 squared plus 7 times negative 1 plus 1. So remember, negative 1 squared is just positive 1, so that would just be 8. And 8 minus 7 is 1, and 1 plus 1 is 2. So that is one way that you can work this problem. I do want to show you another way. Let's say that you didn't have to do this first. You were just given straight this. Maybe you were given your functions, and you were told find f plus g of negative 1. You could separate f plus g of negative 1 out into f of negative 1 plus g of negative 1. This means take negative 1 and plug it into f. So here's our f. We're going to take negative 1 and plug it in there. 3 times negative 1 squared plus 2. And then plus take negative 1 and plug into g. Well, g is all of this. So that would be 5 times negative 1 squared plus 7 times negative 1 minus 1. So that's a lot more writing, in my opinion, but you can absolutely do it that way. And sometimes it is quicker to do it that way if you have like not had to already do the f plus g of x. But that is completely up to you how you want to do it. So I'm just basically offering you some options, and then you pick what works best for you. And this obviously is going to give you two as well. Okay, moving on to the next one. We are given two different functions here. This is 2x squared minus 3x plus 1. And then we have g of x is 3x squared plus 2x plus 1. And this one says find f minus g of x. Now, I want to make a really important point here. How you do this matters. How you write this next step matters. When we write f of x minus g of x, we're not just saying minus the first term in g of x. We're saying minus all the terms of g of x. So I normally am going to write this as writing the f of x function, then minus, and we're going to put parentheses and then put the g of x. So let's do that. Our f of x is 2x squared minus 3x plus 1. But then we're going to do minus parentheses 3x squared plus 2x plus 1. Now, what does that do different than not putting the parentheses? Well, that makes me distribute that negative, or a negative 1, if you want to look at it that way, across g. So let's do that in this next step. Really, really important that you remember this. So 2x squared minus 3x plus 1. minus 3x squared minus 2x minus 1. Now that you've done that, now you can have like terms. So we've got 2x squared minus 3x squared is just negative 1x squared, which is negative x squared. We've got negative 3 and negative 2 is negative 5x. And look what happens to the ones. 1 minus 1 really just cancels out. And that's my answer there. So negative x squared minus 5x is our answer. But again, you need to put a star here and just remember you are distributing. Distribute the negative. Really, 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 really important. Okay. I see a lot of students miss this on the test. So that's why I'm making a big deal of this. Let's look at our next one. This one, we have f of x is x minus 2 and g of x is 2x minus 3. We want to find f times g of x. So when you just see fg, that's what it means. What we're going to do when writing this one is we're going to have f of x in parentheses and g of x in parentheses. So let's do that down here. We're going to have f of x in parentheses. That's going to be x minus 2. And then 2x minus 3 in parentheses. That allows us to multiply everything, both terms together. Now here, this is going to be, however you want to do this, double distribution, FOIL method, box method, use whatever method that you want to use. I'm going to use double distribution, which we've done when this is basically backwards factoring. Okay, so we're going to take the first term, x, multiply it by 2x minus 3. We're going to take the second term, negative 2, multiply it by 2x minus 3, and then do distribution twice, which is why I'm saying double distribution. So x times 2x is 2x squared, minus x times negative 3 is 3x. Negative 2 times 2x is negative 4x, and negative 2 times negative 3 makes a positive 6. And then we add like terms to get 2x squared minus 7x plus 6. Okay, so definitely make sure you know how to do that because you're going to end up doing that a couple more times. And we have done this before, it's just mid-a-minute. All right, so that would be multiplying. And then lastly, let's look at our dividing. So when we divide, this is our f of x over our g of x. Okay, so f of x will be in the numerator. In this case, that's going to be x minus 2. G of x will be in the denominator. In this case, that's 2x minus 3. And crazy enough, that is the answer because we cannot cancel out anything. So even though we have x on top and bottom, the only time you can cancel is if there's multiplication going on there. And in this case, we've got 2 terms and 2 terms. Nothing's being multiplied there, so you can't cancel the x's or the 2's. Okay, so this ends up being the answer, x minus 2 over 2x minus 3. However, we have previously looked at the domain of a rational function. And so this ends up being rational, as in it's a fraction. It has a denominator. And so because of that, when we do this function operation of division, we end up having a denominator, and that means our domain is going to be restricted for this division function. So for f divided by g of x. Now, how do we find the domain restriction? It's the same way that we did when we did the rational functions and we were looking for the domain. We don't want the denominator to equal 0. So we are going to take this denominator, 2x minus 3, and say, hey, this can't equal 0. And we want to find what value that is. So add 3. 2x cannot equal 3, and divide by 2. And we get x cannot equal 3 halves. As a quick note, this is not really asking for the domain. It's asking for the domain restriction. So it's basically saying, hey, what number are we having to take out here? And it cannot be that number because if it is that number, we're dividing by 0. Okay, so that gives you a quick rundown of all the different operations, add, subtract, multiply, and divide with 2 different functions.